All right, here we go. Let's go ahead. Let's just go ahead and click on this, and you can see what I was talking about here. Most of the first few questions. Let's click on this. There we go. Have to do with the Derek Williams video and the Derek Williams video and the Stephen Curry video, and those are highlighted in red on the thing, so you're not digging around looking for them. And there's just some things you just have to watch it. Now this one is interesting. The question number 8 is, and I'll just this is kind of a gimme what the answer is. Question number 8 is interesting because most people don't realize that the circumference, that the diameter, that not the circumference, but the diameter of the distance across of the rim is almost twice. It's 18 and a half inches, whereas the diameter of the basketball is 9 inches. So it's actually, or I might have that backwards. It might be 9 and a half and 18 or something like that. The diameter of the basketball is 9 and a half. That's what it is. So the answer to this one is the second one. All right. So go ahead and pick that one. I put the half in the wrong spot, but it's like double. People don't realize that. They think, oh no, there's no way, but you see it all the time in shoot arounds when with NBA players, and their nets are much more high class. But back in the day when we were, back in the day when I was playing on my driveway all the time, I had the best driveway, and so my dad put up a good goal for the neighborhood, and we played back. But I'd be shooting around when you get a new net, which was always fun. Two balls would get stuck in there all the time because two would go in at about the same time, boom, and they get stuck. Anyway, so there's the Discover magazine. Okay, so here we go. Questions 12 through 15 are tricky. We are now going to compute the hang time and velocity of a 24-foot Stephen Curry three-point shot. Yay! We'll assume, now here's what I'm doing. I'm assuming that the ball left from 8.5 feet, and we're going to calculate the time when it returned to 8.5 feet. So that because when he jumps and releases, and I might be off by a few inches, whatever. But this just works out the best. It's a fudge factor that, and when I did the calculations, they actually came out pretty close. Therefore, we can treat this as like news. All right, so the ball was launched at an angle 51 degrees and traveled 24 feet before returning to the launch height. First thing, convert 24 feet to meters because in the second question 13, we need neglecting air resistance. Once the ball left Steph Curry's hand, what was the only acceleration acting on the ball? Neglecting air resistance. Okay, because there's going to be a little drift. There's going to be, and especially since he puts that backspin on it, which we found between 2 to 3 revolutions of backspin on it, that's going to cause a little bit of drag too. That will affect the ball somewhat, but it's going very slow. It's got so its drag is very minimal compared to like a soccer ball or baseball, which goes much faster. Okay, so the Magnus force on a basketball is going to be negligible because you're not getting 27 revolutions per second. You are per minute. You're getting 2 to per second. You're getting like 3 to 4 or something like that. Okay, so much different, and the velocity is much lower. So the Magnus force is almost non-existent, except unless you drop it off a huge bridge and it's got a lot of time to pick up a lot of speed while it's going down while it's being dropped off that bridge from that one video we saw in the last lesson. Okay, so that's it. Now, I'm going to stop here and I'm going to show you how I came up with these formulas that I'm asking you to use in this lesson. Because it's crazy. But it's a thing that we do in science, in the sciences, all right, is we look at, if we've got two unknowns, we've got to find a way to, well, if I can get this, then can I plug this into here and get that? And that's what we're going to be doing. So I'm going to go ahead and punch out here.